Where is everyone in here? I have candy. All of a sudden, people don't want candy, I guess.
Gloria's coming a little bit later.
You don't give candy to late students.
Do we get more because we came earlier than you did?
No, I was busy doing something called the Mitsunobu reaction. Okay, we're about to start. Okay. So, her name's Ashley, right? AC.
Yeah, actually, Chelsea.
Ashley, why are you not here?
No, that's the right Ashley.
Bro, I'm just kidding. Okay. So Ashley, okay, never mind. Okay. Okay, so what problems do y'all want to go over today? Because it is test week, right? So we want to make sure we tackle the problems that y'all are struggling with the most. Maybe NMR spectroscopy. I'm just kidding. That's not on this exam.
Yeah, you have to know mass spec as well.
Not for this exam.
Oh, no, we have to make our lab.
Okay, I can't. So in the chat, what problems or what topics do you? Yes.
Can you explain calorimetry, just like how it works, like the theory behind it? I don't understand it.
It's on your lecture slides.
We need that for.
Okay.
Can you explain it?
So let's see, how would I explain bomb calorimetry? So because coffee cup calorimetry is at constant pressure, right? Because the coffee cup is not sealed to where the pressure constantly equilibrates with the external atmospheric pressure. Bomb calorimetry, on the other hand, is a sealed container, which allows for the pressure to be different within the calorimeter, meaning when the pressure changes, you know, more work can be done, right? Because P delta V to that. However, because it's honestly, I'm not exactly sure off the dome the best way to explain bomb calorimetry, the theory behind it. I know how to solve the problems though.
Maybe want to pull up a picture of it.
Can we do one?
Maybe I want to pull up a picture. What if I don't? Where would bomb calorimetry be? So it's constant volume calorimetry. Okay. So it looks like because it's constant volume calorimetry, since the delta V is equal to 0, there is no work done. Thus, the change in internal energy is equal to the amount of heat that's transferred in the reaction. And have y'all gone over? Y'all haven't gone over this, right? This is later. Dang, week of the test. Y'all need to start studying this if you haven't already. Okay. So again, in the chat, please tell me what problems you want to go over today. Today, I am open to do whatever y'all want to do.
There have been some suggestions for state functions.
State functions. Okay. Let's see, wait. We went over state function in my class today. I would appreciate some practice problems on that. Okay. I'm not sure. I don't have any practice problems on state functions in this thing because it's not something that they're going to ask you on the exam. Like which of these is a state function? You just need to know that a state function just depends on the final and initial states, right? So are you able to exit out of that or move it to the side? So something like displacement, which in physics we denote delta x, is equal to the final position minus the initial, right? So say you started here and you took this path around to get to this ending position. The state function would be the displacement, which is from one point to the other. So this is our displacement. It's just how far you travel, right? But if you were to ask about the distance, that would be a path function. It depends on the path taken, right? So you would have to take into account all the all this area that you walked here and then here and all the way around. Distance would be your path function. So again, displacement or state functions only depend on the final state and the initial state. So final minus initial. And your distance would be a path function, right? Does that make sense?
Yeah, that kind of makes
Grasp
sense.
that?
So would it be like like when it's talking about like a change in
What
blank,
chapter
would that be a
do
state
y'all think
function?
you are having the most trouble with? Yes, Adi.
I think with the bomb calorimeter, how do you find delta H of or energy of combustion? Or I don't know what it's called.
So you remember delta H is just Q reaction over the amount of moles. So you need to find the Q using,
This the delta T formula.
so yes, that's the amount of energy absorbed by the calorimeter. So like there was a problem here. I can actually go to
64 is,
64, that's the one. Is that the one I went over on the video?
oh, I didn't watch. Yes.
You didn't watch the video? That's interesting. Why do I put up videos? To get 2 views. Okay. 64.
It gives you the energy of combustion, but right, if we had to find it, how would you?
So the energy released by combustion of benzoic acid is 26.42 kilojoules per gram. Is this question?
Yeah, but like if it had asked us, like, how do you find delta H of combustion? It's like, how would you? I think there was something like that in Alex. I didn't take.
I guess
Okay.
that should be.
So is that, so what's your question about this problem specific?
Oh, it's not on.
Okay, so you're asking about like how to find delta H of, okay, so I think that's something like this one here.
Yeah, but
So where we had to realize that the heat lost by the calorimeter or the heat lost by the reaction is gained by the calorimeter, right? And we know that delta H is equal to Q of reaction, right? So in order to solve for delta H of combustion, we have to find Q of reaction over N. We find Q of reaction by setting, by just converting the negative sign to the other side, right? By multiplying by -1. And then we plug in our C-cal, which we found in part A of this, times the change in temperature for this one specifically. And that'll give us the heat lost by the reaction, right? Which then we just plug into that general equation that we already know that we're supposed to use. Divided by the amount of moles. And then it gives us our final answer of, yes, right here.
Thank you.
So that's how you would remember when you're asked to solve for delta H of reaction. You always have to remember delta H is, you have to remember this part right here. Delta H is equal to Q of reaction over the amount of moles that either was produced by the reaction. It depends on what it's asking for. So in this problem, it's asking for combustion of acetylene. But in the previous one, it was saying calculate delta H per mole of AgCl formed. So you have to make sure you are aware of what that's asking.
Would that be considered delta H of formation for AgCl form? Like,
No, because Ag plus is not in its natural state, it's an ion. And then Cl minus is not in its natural state, it would be Cl2 gas. It would be, yeah, so let's do a couple of those problems. So what I'm gonna do, go back up here, that's the key. So so the delta H of formation, you're gonna have a couple problems like this on your exam, maybe just one, because the physical content on these exams. But the delta H of formation is the amount of heat either lost or absorbed by a reaction when it forms 1 mole of a compound. So by that, I mean, so like say you want to form water, this would be the balanced chemical equation for water. So you would do, it has to come from its element. So it would be H2. And we know H2 is naturally diatomic, right? So that's why it's H2 and not H alone, right? Plus O2 gas produces H2O. So, but we need to balance this, right? So you would do 2 here, and 2 here to balance. However, that's not considered a delta H of formation reaction because we're actually forming 2 moles of product. The definition of a delta or heat of formation reaction is the heat required or the heat absorbed or lost by a reaction in the formation of 1 mole, right? This is 2 moles, it has to be 1 mole. So with that,
I'm so sorry. Could you repeat that one more time?
in order to solve this problem, you would have to divide everything by 2. So you get 1 mole of product. So that would cancel that. And you would have a 1/2 here. So that
I'm
would
so
be
sorry.
the correct
Could you,
delta, the heat of formation reaction for water. You have H2 gas reacting with 1/2 mole of oxygen gas to form 1 mole of water. Does that make sense? Yeah,
So your end product needs to be 1 in 1.
1 mole.
That's
all-
it?
Yeah, all the time. That's on the exam, you're probably gonna see something that gives you 2 moles of product, even though like it's coming from its elements, but you have to realize that's not true, right? It can't be that because it has to form 1 mole of product. Yeah,
Oh, okay, 1 mole.
1 mole of product, yeah.
wait, I have a quick
So
question.
let's go through these problems. Make any changes needed in each of the following equations so that the enthalpy change is equal to delta H of formation. Okay, so for the first one, we want the enthalpy, the delta H to be equal to delta H of formation. So for, what would we have to change for A? Is it coming from its elements, going to 1 mole of product?
It's Cl2,
Why?
that's the natural state.
Yeah, so chlorine is naturally occurring as a gas, as diatomic, right? It's diatomic, so this is incorrect. What they have here is incorrect because it's Cl gas. Cl is not in its natural state, or it's not in its elemental form. So it would be Cl2 gas, because we know chlorine's diatomic, reacting with sodium metal. It has to be solid. If you put sodium aqueous with a plus charge, it's wrong. It has to be sodium metal, because that's how it is found in its natural state. Forms sodium chloride solid. And again, does everything check out? Everything's in its natural state on the reactant side. We form 1 mole of product. So does that check out? Yes. What about B?
Wait, don't you need a balance?
Yeah, you, yeah.
Because you have
Oh,
2.
yeah, you're right, yeah.
And
So
you need to-
how would we balance this?
2.
It would be 1/2, right? Because we want, if we multiply this by 2 and that by 2, you wouldn't be getting 1 mole of product, right? So in order to balance it to where you get 1 mole of product, you have to divide this one by 2 or multiply it by 1/2. Okay? That makes sense? How we feel about that? Yeah?
I have a quick question. Can you guys hear me?
Okay. How about the second one? B.
Flip it.
Flip it. Okay, so they said flip it. So 2Hg plus 1/2 O2 gas yields H2O gas.
And then when you flip it, if we were to do the enthalpy, you would make it a negative, right?
Yes, yeah.
Wait, why do you have to flip the reaction? Oh,
We
because
can't hear y'all, Kristen. Rich, are you able to figure this?
Can you hear me now? Oh, no. Can you hear me now?
You know, I guess the volume was off. Yeah, if we go up,
You can hear me now, right now?
yeah, we can hear you.
Okay, good. So I just had a quick question. So this is for the delta, what is delta H dot, degree F? What's this called again?
So this is the heat of formation. So
Okay,
you've seen on Alex, it'll give you like that big table full of heats of formation values. It's just the amount of heat either lost or gained in the creation of 1 mole of product. So
okay,
and here it's ammonia. In this one, it would be hydrogen fluoride.
okay. But in order for D to work, D's wrong because it's not in 1 mole. It has 2 moles of the product.
Yeah.
So you'd have to divide everything, by 2, right?
Yes. So then,
Oh, okay.
so let's do that. You would get 1/2 H2 gas plus 1/2 F2 gas produces 1 mole of HF gas. Does that make sense?
Okay, yeah, that makes sense. So it has to be in its natural state, whether that's like diatomic or whatever. And then you just have to like change the formula in order to make it 1 mole of product.
Exactly, yes.
Okay, and then will it like, you said that we could expect some questions like this on the exam. Will it like tell us like, oh, find like, you know, formation, heat formation, or will it like have the symbol, or like how would we know that we need to do this?
So it will say like, which of these reactions is a correct depiction of the heat of formation of a substance? Yeah. Okay.
Yeah,
So-
thank you. Sorry about that.
Go ahead.
I have a question.
Yes.
For B, isn't hydrogen, it needs to be a diatom?
Yeah, so.
Are we
weren't-
getting there?
We weren't done with this.
Oh,
the some
sorry.
type of question. So diatomic, yes. So B, we know, even though we had flipped it, we realized that hydrogen's diatomic, so it has to have that there, right? But we also know that these mole to mole ratios are whack, right? So it should, what should it be?
1.
Should be, that should be gone, and that would be our answer right there. Yes? Any questions? No questions?
So basically, like use the equation as like a reference, but keep in mind like the rules of like the element.
Yes, yeah.
Okay.
Yeah, how about C?
Just be the same.
Is it correct?
Why is there an
Equal
equal
sign.
sign?
That must be a typo. Y'all won't give any slack here. That's an arrow. Okay, so I hear people saying this is correct, but look closely. Thanks, Jake. It looks like an arrow, right? Look closely. Is this right? Jake, what do you think? Is this right? I know Jake is on top
We'll
of it.
figure it out.
They're just gonna see the states.
So it's 1/2 and 2.
That is another type. So assuming that has gas right
There's
there.
no gas.
What do you mean? There is a gas sign.
Oh, yeah.
Well, okay, so there's nothing wrong with this one. This one is the correct answer. Had this been on a state symbol, see this guy Jake, I don't know what you're talking about. There's a state symbol right there.
Scott always talking about being #1, but makes typos on his review.
Oh.
Rich, how we come do number 56 for the class?
Right.
Yeah, I'm just kidding. I'm not gonna put you through that. Okay, so how about 56? So copper 1 oxide, also known as Cooper's oxide, can be oxidized to copper 2 oxide. Given delta H of formation of copper 2 or copper 1 oxide, is that find delta H of formation of copper 2 oxide? This is a good one. Very good. This is going to be given to, or not given to you. You're going to see this on the exam. So what do we know? Let's think about a very general equation when we talk about heats of formation. And we know that the delta H of reaction is equal to the sum, let me write this out. So sum of the delta heats of formation of the products. And that F is not enough, right? Minus the sum of the delta H of formation of reactants. So with this equation, try to solve this out. How do you have your money up? Good.
You already finished.
She actually finished this whole document because she's on top of, she's a top scholar.
Because I have no like.
That's because, yeah, she also has. I'm just kidding, I'm just kidding. Okay. Hey, Homework, you know how to do this?
Yes.
Okay, I want to see the right answer in about 30 seconds. I'll call on you to give your answer to the Zoom students, my Zoomies. All right, 15 seconds, Tomer. Yeah, sorry. I didn't mean to offend anyone by calling them Zoomies.
It's not offensive. I just thought it was funny.
Yeah, y'all are my Zoomies, and then these are just my in-person.
Wait, you did what?
Just
Okay, so Homer, what did you give for an answer? Yeah, these are my roomies who get candy because they're here. All right,
so,
go ahead.
so you have you're given. So you do negative 146.0 kilojoules equals,
Okay, so you're saying because this equation says delta H of reaction is equal to this minus this, and we have delta H of reaction, we can plug it in here.
yes.
Okay, so negative 146 kilojoules. I'm not gonna do the per mole just because
Mhm.
it doesn't matter right now.
And then you set that equal to X minus negative 160.
Okay. So you have to also remember that you have to multiply by the amount of moles per reaction. So by the products, we know that there's 2 moles of copper 2 oxide. So you would have to have a 2x here.
Okay.
All right. Because remember the heat of formation for copper 2 oxide is assuming 1 mole of copper 2 oxide. So you have to take into account that there's 2 moles being formed here.
Mhm.
All right, does that make sense?
And you would do the same thing for reactants.
Reactants
As well.
exactly. So let me ask, what is the heat of formation for oxygen gas? We're not giving it, why? What's the value of it?
Oh, it's zero.
It's 0, right? Because
It's in its elemental
yeah,
form.
to form something that's already formed,
Yes.
it takes no energy, right? So anything in its natural state always has a heat of formation of 0. So that's like oxygen gas, nitrogen, fluorine, chlorine, bromine, iodine, hydrogen, all those things, any metals
Mhm.
that are in their solid state. They have a delta H of formation of 0. So we know the delta H of formation for this is 0. And then we're given this, right? We're given the delta H of formation of the copper 1 oxide. So it would be minus, and then we have to plug that part in right here. So minus 168.6 kilojoules. All right, Maria, any questions? I see you're a little lost.
Wait, did you learn this on Alex? Okay, I haven't done Alex, that's why I'm lost.
So ask your questions.
Okay, so I understand the products from the reactants, right?
Do you understand why I'm multiplying by 2?
Because there's 2 copper oxides.
Yeah, but we're trying to find the delta H of formation, right? Of copper 2 oxide. And that's only the delta H of formation for copper 2 oxide is the heat associated with forming 1 mole of copper 2 oxide, right? So whatever number we get when we solve for 2x is the number for twice the amount of copper 2 oxide. So we have to divide it by 2 in order to figure out for 1 mole. Let me write out so if you were to do the formation reaction for copper 2 oxide, it would be copper metal plus O2 gas. We would have to divide that by 2, yields CuO, right? So that's the That's the formation reaction for copper 2 oxide, right? So we know that the delta H of formation is what we're trying to find, right? That's equal to what? That's what we're trying to find, right? And we know that only takes into account 1 mole of copper 2 oxide. But this thing has 2 moles of copper 2 oxide, meaning we have to add the 2 here, so that way we eventually divide it by 2 to find the amount for 1 mole, which is the delta H of formation.
So you wouldn't divide the delta H of reaction by 2?
So let me do the math first, and I'll show you, we do eventually when we're solving for X, because X is delta H of formation for copper 2 oxide, right? We just have twice of that because we have 2 moles here. Does that make sense? Okay, so when we solve for this, you get negative 146 kilojoules, and the negatives cancel out to make it a positive. So we would actually have to subtract it over, right? So minus 168.6 kilojoules is equal to 2x. And we would divide by 2 to find X, which is our delta H of formation of just copper 2 oxide, right? And when we do that, we get negative 157 kilojoules equal to delta H of formation. Let's see you. How does that? What are y'all feeling? Any questions? Answer or ask your questions. The test is on Friday. Come on, ask a question, or else you don't get candy.
Good. But if it wasn't oxygen, like let's just say the other thing you're reacting with had that wasn't in its elemental
Yeah.
form and had a
Delta H.
Had a delta H.
Not 0.
you would add it to the other one.
You would add it to the reactant side. So
Yes.
product minus the sum of all the reactants. So
Okay.
I think there's one in here. Oh, that one.
Is this Hess's law?
This is not Hess's law. Hess's law is like,
No, wait, can I join in?
Go for it.
so Hess's law is like 54, where you have to manipulate the reactant. You have to manipulate a set of reactions in order to get an overall reaction. And I did this one on our YouTube channel, so it's been posted. I took the sweet time of my, Sunday night yesterday to do it for y'all.
What's the YouTube?
It's called, here, put it in the chat.
Yeah. Also, by the way, thank you for doing that, because I know that's your weekend, so appreciate that.
Of course. Anything for my Zoomies, my roomies. Okay. So how do y'all feel about that?
Can you explain why we ignore the 1/2 again for oxygen?
So on this part,
Yeah.
so in order to form 1 mole of CuO, okay, so normally you would balance it like this. You would say, let's put a 2 here and we'll put a 2 here, right? And that's balanced. But that's not a heat of formation reaction because you're forming 2 moles of product. A heat of formation reaction is the heat required to form 1 mole of product. That's the definition of heat of reaction. So in order for that to be the case, we have to get rid of these 2's and we divide by 1/2 here. So that way, think of it like you just take the O, you have 2 O's, you divide it by 2, you get 1 O. That's what we have in our product side. Does that make sense?
Yeah, it was just weird how we ignore that. Like we pretty much like don't use that in the equation.
Oh,
And
this,
you-
yeah,
you
so,
the two. That was the weird one.
yeah, you're talking about this part or?
Yeah, because we don't use the half moles, but we use the 2 for moles.
Oh, yeah, because the delta H of formation of oxygen is 0, so it doesn't, so, yeah, exactly. So 0 times 1/2, 0, right? So we wouldn't even include it in. Had it been something else, we would have. Okay, so.
Or if it was like part of like a compound, like if it was 1/2 H2O.
Yeah,
we would use
exactly,
it.
exactly.
Okay.
Any questions? How about I let y'all do 57, try it. It's the same exact principles. But let's try to apply what we learned from 56 onto 57.
I have a very quick question. Will you post the answers to the solutions? Like what, like, do you plan on posting the answers to this?
I do plan on eventually posting them. It's just, I feel like if I post them now, no one's gonna be showing up to my sessions.
That's valid. Well, you're a good teacher, so I think people would show up anyway.
Yeah, that's true. And I am a teacher. That's right. But I don't get paid teacher salary.
You should.
Damn, that sucks. You should.
You should.
I think it's Siddiqui. I'm just kidding.
But, but will you,
Stay
like,
easy.
when do you plan on posting the solutions?
So probably, I'm thinking Thursday, or, because my last session would be on Friday, but that would be for all the people that, I mean, everyone's gonna come on Friday, right? Because, yeah, everyone's. Your exams on the YouTube video, not go problems. Yeah, we can do, how about after this problem, we'll go do some Grand's Law problems, and I'll start looking for them, and we'll go through them. okay?
Hey, you know what I missed this?
We're gonna go over the, I'm trying to think of the bomb calorimeter.
So I went over a bomb calorimeter problem. Channel, if you-
Maybe posted yesterday.
Yeah, I posted it yesterday.
Okay.
So it's one of the ones here,
Why did he?
and,
Yeah.
but yeah, I think that I only had one bomb calorimeter problem in this
This
there.
there, last.
Yeah, and I already went over it on YouTube, so you can check it out later.
What's that?
Now, there should be more long calendar problems on there. Maybe like 2, 3.
What session did you do that? Or you did it?
I did it yesterday at home. I recorded it and posted it. So go ahead and try number 57. Let me know what y'all.
This is so easy. Why was he freaking out?
Yeah, that's it.
Adam?
So the next problems we'll do are 30, 31, and 32. Okay. How much more time for this problem? 2 minutes, I can give you 1 minute. Just because we have to make sure we reserve time for the rest. Do you know if Jason has a session today?
Yeah. Yes.
I remember.
Siddiqui is definitely my favorite professor.
And I'm
in
freaking
the
out.
chemistry department. Aside from Dr. Apple. And Dr. Thomas. And Aggie. And John's. And Doherty. But he's up there for sure. Dr. Thomas, she's great.
Yeah, she blew up quick.
I mean, I was telling them earlier, should to take Dr. Thomas. But yeah.
Yeah, she's actually really good.
And then second case scenario.
And
She goes up quick.
she goes up quick. I don't think she will because she has like 150 students in her like class size is 150, so those don't fill up that.
What's that?
Okay, Maria, time is up.
Oh, I'm done.
You gotta, did you get an answer?
I don't want to tell you my answer.
What did you get?
Um,
Just tell me. Can you get,
I lost the negative sign on it.
okay, maybe, okay,
So it's 227.
that's the right answer. The right
Really?
answer, yeah, okay.
Yeah.
So let's go over what you did. So, the equation we have to use here is the delta H of reaction is equal to the sum of the delta H of formation of the products
And my points.
minus the sum of the delta H of
Wait,
formation
Did I get an A on it?
of reactants.
Oh, yeah.
Right?
Thank
You
you.
got an A+.
Really? Do I get an A?
Okay, so, Maria, these mics pick up everything.
Just
And these for after the session.
Oh, okay, I understand.
Okay, okay. Okay, so this is the equation we want to use, right? So let's see what we have first. We know we have the delta H of reaction. Sometimes we'll be asked to solve for this, but we have it here. We have the delta H of formation of carbon dioxide. And then delta H of formation of water. And then delta H of formation of acetylene, C2H2. So knowing that, it's asking us, oh, no, wait, just kidding. We don't have the delta H of formation of acetylene. We are asked to find the delta H of formation of acetylene, which is in the products or in the reactants, right? So if I were to plug in everything we have delta H of reaction, which is negative 12,255.8 kilojoules. And this is equal to the sum of the delta H of reaction of the products. So we have 2 moles of carbon dioxide, so we can write 2 moles times, and the heat of formation for carbon dioxide is negative 393.5 kilojoules. And we have to add to that the heat of reaction, the heat of formation of water, right? Since we have 1 mole of water, it's gonna be negative 241.8 kilojoules. Okay, so that's just the product side. So that's the sum of all the heats of formations for the products. Now, from that, we're gonna subtract the sum of all the heats of formation from the reactant side. We would have 5/2 moles of oxygen gas, but we know that the heat of formation of oxygen gas is 0 because it's already in its natural state. So I'm not even gonna include it, but actually I'll just include it for simplicity, so that we all see. So 5/2, but we know that the heat of formation for oxygen gas, O2, is 0. So 5/2 times 0, it just goes away, right? And we're gonna add to that the heat of formation of acetylene, but that's what we're looking for. So we're gonna say X. Okay. Any questions so far? No? Nope. Palmer, ask.
Why 2x at the beginning for products?
So it's actually 2 times. My bad. So 2 times negative 393.
Okay,
Um,
everything else, yeah.
yeah, so we only have 1 X here, and it's the one that we're solving for, which is the heat of formation of acetylene.
2H2.
Yeah.
Okay,
So when we solve for X, I'm not gonna do all the algebra because it gets very. Actually, it's not that bad. All you have to do is add this to the, you can say plus X and plus 1255.8 kilojoules to add everything to one side. And you would get an X is equal to 227 kilojoules per mole, which is equal to the delta H of formation of C2H2. So this would be your. Okay,
So I have a quick question. I got that answered, but I got it negative.
interesting.
Minus X.
So, like
Oh,
I took all the math part.
did you distribute this negative into here? To get
Oh.
negative X? And then you would have to divide by,
+1 or whatever,
yeah, you'd have to divide by -1.
-1. Oh, okay. That's probably what it, oh yeah, I changed it to a plus sign by mistake. Okay, yeah.
Yeah, don't forget about that on the exam, that these are the problems that the pluses and minuses get really hairy, because you got all these negatives in here, and you got this negative out here that's trying to make your day horrible. And yeah. Okay. Any questions on that problem? Any questions? In class?
So
Yeah,
I would
go
just
ahead.
divide that by, I'll just divide both sides, like, hold on, sorry, let me backtrack. So I got like negative 227 equals negative X. I'll just divide both sides by -1.
You can divide it by -1, or you can multiply by -1. They both do the same thing. They cancel out.
Right. Okay, sounds good.
Any questions? Maria, how do you feel now that you did it?
It's actually really simple.
Exactly, right? Just plug in what you have and solve for what you're looking for. Okay. If there's no more questions, we're gonna go to question 30, okay? So, any more questions? Do the people online?
Or just related to that problem that we just did.
It could be about anything, but I mean, ideally, I was just asking about this problem, but if you have another question.
I can wait till after because they're, yeah.
What's your question?
How do I identify, like they give us a list of compounds, how do I identify which one's a strong liquor? Like,
Okay, so that goes back to just pure memorization of which are strong electrolytes are your strong acids, which we have to memorize. Right, that's nitric acid, sulfuric acid, hydrochloric acid, hydrobromic and hydroiodic, and then perchloric acid. All those are strong acids. Anything that's not those 6 is considered weak acid, weak electrolyte, right? So then you also have to think of soluble salts, which are anything that dissolves in water. So solubility rules. If you haven't memorized your solubility rules, it's not too late. Start today. Start today. Do a couple hours before you go to bed of just solubility practice problems. And maybe we can do something like that tomorrow, okay? Or on Wednesday. Yeah. Okay, so number 30 is where we're gonna go here, so. Example of an unknown gas effuses in 11.1 minutes. An equal volume of H2 in the same apparatus under the same conditions effuse in 2.42 minutes. What is the molar mass of the unknown gas? Okay. So how would we go about this problem?
Graham's law of effusion.
Okay. Graham's law of effusion, which is
Rate over X over rate of
So-
H2 is
rate. I'm gonna say rate A over rate B,
Equal to the square root of molar mass B.
square root of molar mass B over molar mass A. Okay. So. I'm actually doing the wrong problem. I meant to do 30, which is why I will go back to 30. Okay. So first we need to figure out what the rate is for A. What's the rate for the first gas? And you can assign it either one. So let's just say rate A is the rate for H2,
We have to do 1/T, right?
and then rate B is just rate X of the unknown, right? And we'll change all these variables so that way they match up. So H2. Okay. So with that, what's the rate again for H2?
over 2.42.
Yeah, so you have to realize that you can't just plug in the time here, right? That's not the rate. The rate would be 1 over the time. So let me write that equation. So rate of anything, so rate of X or whatever is equal to 1 over the time it takes to effuse out of the container. Knowing that, you can say rate of X, in this case, the unknown sample, is 1 over 11.2 or 11.1, which is equal to 0.09. And then it would be inverse seconds. So that would be the rate, right? And then rate for H2 be 1 over the time it takes to effuse. And the time it took to effuse for hydrogen gas is 2.42 minutes. So it'd be 1 over 2.42, which is equal to 0.4132. Okay, so from here, what we can do is, let's just box this out, because we found what our rates are. And we're gonna use this equation here to plug in everything we have.
For like the 0.09 s, wouldn't it be like minutes?
Is it minute? Oh, yeah, it's minutes. Sorry. So it would be minutes inverse, and that's because the units are in minutes, right? So inverse minutes would be the time or the units for the rate here. So when we plug in everything we have rate of H2 is. Actually, do you want me to solve for the variable? I'm gonna solve for the variable first, because that's how I did it on the key, and I think it's a lot nicer because then you plug everything straight in. So if we solve for molar mass of X, we have to square both sides, right? To cancel out the square root. So you get rate of H2 over rate of X all squared. And we're going to multiply, this is equal to molar mass X over molar mass of H2. To solve for molar mass of X, we have to multiply both sides by the molar mass of H2. So you would get molar mass of H2. And that would cancel out. So that would be the equation. You would plug everything you have into it. So you would get molar mass X is equal to the rate of H2, which we said is 0.4132 over the rate of x, which is 0.09, all squared, right? Times the molar mass of H2, which is 2, right? Times 2. And this would get you a molar mass of approximately 42.2 grams per mole. Which I'm not sure what that molar mass corresponds to. It's just asking you to find the molar mass, not identify the gas. Because the molar mass, the equation we solve for the molar mass of the unknown is these rates over this rate squared, right? Times the molar mass of H2. Molar mass of H2 is 2, right? Okay, so that's why I multiplied by 2.
So you can just do like 2 over 1 over x, square root of that.
2 over 1 over.
Or the square root of 2, 0, 1 over x. Right, so you don't have to multiply by 2 yet.
I just solved for my variables and plugged in everything I have here. That's what I did. Is that, I'm not sure what you were trying to say.
I'll figure it out.
Yeah, I would just solve for the variable that you're looking for
Yeah, it's the same thing.
and then plug in everything you have of it.
I have a question about the equation.
Okay.
So you have like the rate of like H2 on top, but then on the equal side, on the other side, you have the molar mass for H2 on the bottom.
Yes.
Why is that? Is it just how the law is like written?
Exactly, yeah, that's. I couldn't tell you how this was derived, but I just know that this is how the law is written. So I'm sure somewhere in whoever, I guess Graham, it's Graham's law, so whoever this guy Graham is, he derived it, and when he derived it, it just so happened that it was the inverse relationship. Look into that.
Okay, thank you.
Okay, any questions on this problem? No, ask your questions now, because you're gonna do number 30, and whoever answers it first, assuming that they haven't done it yet, will get an extra piece of candy.
What? Are you serious?
So, all right, that is not.
Which one are we doing now?
Number 30.
Look at that beautiful picture on there.
Okay, number 30, go ahead. Starting now,
I'm done. Can I get the?
you get a piece of candy, no? You already get the piece of candy that you already earned,
I got 2.
maybe, because you finished the review. A lot of candy in here. Make sure to get the one that had meat flavored.
Sorry. My notes in class said that it was rate of diffusion of gas 1 over rate of diffusion of gas 2 is equal to.
Are you able to speak up just a little bit?
It says the rate of diffusion for gas 1 over the rate of diffusion for gas 2 is equal to the square root of the molar mass of gas 1 over the molar mass of gas 2.
I don't think, no, that's not right.
So should
It's the opposite.
the molar mass of gas 2 over molar mass of gas 1.
So I would think of rate A over rate B is equal to molar mass of B over molar mass of A square root. If you ever forget, just remember it's opposite. All right, it's always opposite.
It's the same.
You're given time for the day.
I know I got
But
Why is it giving us?
that's what you're saying. If you're instead of finding individual rates. Yes, you can do that. I just do it the way Dr. Armando does it. But I know what you're talking about, because when I took your class, I was like, hey, look at it. Shortcut.
Buddy, I didn't have time to start and do this all day. I really
What do you do?
They don't have the glass.
Oh, your friends.
Not yet. Wait, what form are you reading? The white or the white?
Oh my god.
Or it might be the other one you're already graded. I just haven't graded mine.
Really? I haven't.
Okay, how are we doing on? Okay,
I have it.
I have it.
okay, we got two people. Let's see if they got he raised his hand first. Okay, so I'm gonna let him. what's your-
I say never mind, so let him take it. I
Okay.
think.
What?
0.07.
It's asking for the amount of time it takes,
Oh, crap, okay.
but you're right, that's the rate.
Okay.
So all you have to do is just 1 over rate to find t. Okay. Interesting. Okay, so I'm gonna go ahead and get started because I see a couple people that may be a little lost, and I don't want y'all to feel lost. Okay, so it's saying at a given temperature or a given pressure and temperature, it takes 4.85 minutes for a 1.5 liter sample of HE to effuse through a membrane. How long does it take for a 1.5 liter sample of F2 to effuse under the same conditions? The first thing you should automatically cross out off this question is the 1.5 liters, right? Because that does not affect, because they're both the same volume. It won't affect anything here. And there's nowhere you can plug volume in this equation. Okay. So the second thing I would do is solve for the rate of helium. So it says it takes 4.85 minutes for 1.5 liters sample of helium to effuse. So we know that the rate of helium is equal to 1 over T, the time it takes to effuse, which is equal to 1 over 4.85. Anything else? Right? Which is equal to 0.206. Inverse. Okay, from there, what we need to do is just write out our Graham's law equation, which is, and it's always convenient to put what you're solving for in the numerator, because it'll just make it easier for you, because I'll show you what I mean. So the rate of F2 over is what we're looking for, right? So I'm gonna put it in the numerator over the rate of HE equals the molar mass of HE over the molar mass of F2. And now all we have to do to solve for rate of F2 is multiply both sides by the rate of helium. Time is seconds, but we need to convert the time to minutes. Now you don't need to convert the time to minutes, because as long as the units are the same, it'll work out, okay? Because the rate can be in minutes, the rate can be in hours, the rate can be in days. As long as the units match up for both rates, then you'll be okay, all right? So from here, to solve for rate of H2, it would be rate of F2. F2 is equal to this thing here. Copy. I'm actually going to bring this down here for right now. So times the rate of helium. Right? All we did was multiply both sides by the rate of helium to solve for the rate of F2. So now just plug in everything we have. If we go this way, it'll be rate of F2 is equal to the molar mass of helium, which is what is that, 4 over the molar mass of F2, which is 38, times the rate of helium, which we said is up here. We calculated that to be 0.206. All right. So when you multiply that out, you get a value of 0.0668, which is equal to our rate of F2. But the question's asking for the time it takes. It's not asking for the rate. So to find the time it takes, you have to take the inverse. You use the same equation, except it's rate of F2 now. And you solve for T, right? So we have rate, you just do 1 over the rate equals time. And you would get time it takes is equal to 14.96 minutes. All right. 15 minutes basically. So any questions on that? Okay, good. What about people over here? No questions? You got a question?
I'm just saying it in my head.
What about you? You got a question? Okay, anyone on Zoom have a question?
Yeah.
Where did I get the 4/38? So we solved this equation. We solved for a rate of fluorine gas, right? Which is the molar mass of helium over the molar mass of F2. So when we plug all the numbers in, we know that the molar mass of helium by looking at the periodic table is 4, right? And the molar mass of F2 is twice the molar mass of fluorine by itself, right? So 38. So 2 times 19 is 38.
I have a quick question.
Yeah.
So we like did 1 divided by the rate and got minutes, but I thought 1 divided by the, oh, wait, the time. Oh, I see. Okay.
Yeah,
I see
so,
now.
yeah, so 1 over the time gives you rate, which means if you solve for t, 1 over the rate gives you time.
Wait, 1 over.
I can write it out here, just so.
Yeah.
So rate of F2 is equal to 1 over the time it takes to effuse. If we just solve for t, you get t is equal to 1 over the rate of F2, which is what we found right here.
Yeah. Okay. I get it now. Yes.
Perfect, okay. No more questions. I'm gonna go to question number 32. So this is just more of a concept. Oh, wait, so the rate times time equals 1 always. Wait, so the rate times time. Wait, what? Yes, so the rate times time is always equal to 1. Yeah. Exactly. So like on this part, if you were to multiply the time on both sides, you would get rate times time is equal to 1. Yes. Or yeah. Okay. But I just usually just remember this equation. Rate is equal to 1 over time. Whatever works best for you. But yeah, so number 32 is asking what is the name of this compound? Fluorine? Fluoride. Is it fluoride? I thought I heard fluoride. Okay. So does this gas behave more ideally at 150 degrees Celsius or 20 degrees Celsius? And why, Maria? I thought this went against everything you learned.
It's like people high-fiving each other in the hallway, and if they're going too fast, they can't
Who you
high-five.
high-fiving?
Huh?
Who you high-fiving?
Dr. Armand.
Okay. Yeah, so here we know that a gas acts more ideal the further it is away from its boiling point. So if the boiling point is 16 degrees Celsius, it'll behave more ideally if it's at 150 degrees Celsius rather than if it's really, really close to its boiling point. So that's another idea. We know that gases behave ideally at what, high temperatures and low pressures. But another key point is that they behave ideally the further you move away from its boiling point. So
Either direction or just up?
up, so higher. So like water, 100 degrees Celsius is the boiling point for water. Water vapor behaves more ideally at 600 degrees Celsius than it does at 200 degrees Celsius. Okay, yeah.
So if this was, the boiling point was 100 degrees Celsius, would we pick 20 degrees Celsius?
No, because that would even be a vapor anymore. That would be a liquid or a solid, depending on the melting point. Because you remember, if the boiling point is at 100 degrees Celsius, that means that's the point at which it's going from liquid to gas, right?
Oh.
But if you're underneath that, you're going to stay a liquid or you're going to freeze to a solid. Good question, though. I see where you're thinking about the distance. It's 20 would be further, it'd be 80 degrees further away, right? But yeah, so any questions on that on Zoom? No, yes. Number 33 is not on your, I switched it up because that was too hard of a problem for a lot of the students. I learned something new. Perfect. You can try it out, but just know it's a really difficult problem. No. See, when I was making this review, I was like, I'm gonna make this review harder than the exam, so if they can do this, the exam's a cakewalk, and that's what a lot of students ended up saying after they took the exam. And this question was just too difficult for a lot of students, not for me, I was able to solve it obviously, but
Oh, I didn't do it yet.
yeah, because it's not under, I took it off. I took it off y'all's review. But go ahead, Audie, take a picture, and if you solve it without using,
Is that candy?
no, but if you solve it without using check.
This one's not authentic.
No, this is on the Columbia textbook.
Oh, okay.
Technically, just use that yellow gas law.
Honestly, I don't even know if this is a Jenkins one question.
Doesn't look like this.
I solved it using Jenkins one math, so I don't know. Okay, let's see, it's already 3:30, but let's see, there's one more, we can do one more problem. I'll give you all, you know what, Rich will do one more problem.
Right. We need to finish this last thing.
What
Richard.
problem is it?
I don't know, I scroll through y'all's PDFs if y'all have it up. Or what topic, what chapter are y'all currently struggling with the most?
Six?
Gases? Gases, really? I feel like thermochemistry is the harder one. I mean, not for me, but, yes.
Are we learning anything new, or is like, is thermochemistry like the last thing for this unit?
For this unit or for this test, thermochem's the last thing. But the fact that y'all haven't even finished it and the test is on Friday is worrisome. So please read the.
Oh my god.
Armand.
It's actually P delta P, not delta P. Sadegi wrote that? Interesting. Bro, why are you doing derivatives?
That's what he's doing.
How about you just don't worry about the derivatives for this class?
Wait, what about derivatives?
Wait,
Can we do one like this?
I think
Because I've never seen this.
what is
This is-
this?
Oh, this is.
Yeah.
I usually just check.
There is one on my.
No, not- not-
Subscribe, which
I want,
posted last night.
an explanation.
On my
Because
video.
usually on my explanation, I need to make.
What's the name of it? It's called team entropy. You'll learn what entropy is. Check into
Oh, you, is entropy S?
that one.
Yeah, disorder and everything.
So you want to do 54?
Yeah, wait, will this ever be on the test?
Wait,
though?
that was the one I did last night on YouTube. So it's on a YouTube video, so we're not gonna do that on here, but we can do one that's similar to that.
Yeah, that's fine.
Hold on.
I understand this.
Yeah.
Maybe
it's actually
it's full up. Yeah, so number 51 and 52 are similar to that.
Yeah.
Okay,
Alright.
go ahead, Rich.
Take y'all's pick, 51 or 52. Take your pulse. 52?
Yeah.
Okay. So, alright, so 52 is calculate delta H for that monstrosity, 2NOCl makes N2 plus O2 plus Cl2, given the following reactions. And then it gives you these two reactions, so this bad boy and that bad boy. So what are you gonna go ahead and do? So what's your first step in solving this
Rid the intermediates.
problem? Yeah, that's a good start. So we see here that one of our intermediates is NO. Good thing is, I'm pretty sure we can just cancel it out. Yeah. So NO can go away, NO can go away. So what's next?
Do we have to reverse the
You
second
have
equation?
to reverse the second one, and you have to change the sign of enthalpy and then multiply it by 2.
Mhm.
So you're saying flip the second one and multiply it by 2.
Yeah, so you have to flip the sign and then we do 38.
So it looks on this NOCl gas makes 1/2 CO2, right? Something like that.
I don't think you can cancel things out yet until.
I mean, yeah, this is for demonstration purposes, to show that that can happen.
Yes.
So then flip that,
And then.
so then you'll get plus NO gas,
And enthalpy is 38.6.
38.6.
And you have to multiply by 2 to get your goal reactant.
Yep, you do multiply by 2.
So you want multiply enthalpy by 2 then.
Yep, and that is a value of 77.2.
But how do you know you're supposed to multiply it by 2?
Because you multiply, yeah,
There's 2 NOCl where?
and the goal equation.
Yeah, exactly.
Yeah, so that's why you multiply by 2 and not like 3.5 or something.
Exactly.
So then you get, so when you multiply by 2, you get 2 NOCl, gas makes Cl2, because the 2 and 1/2 cancel, and then plus 2 NO. Right, are we done?
No, don't we have to reverse the first equation?
Yeah.
Yeah, we do have to reverse the first one, so
Negative 9.
You need the N on that.
NO makes 1/2
Sure.
N2,
N2.
plus 1/2.
Yeah, we need N2.
And now what do we do?
Like,
Yeah, but the multiple, that's what you're trying to get to.
Not exactly, there's still 2 1/2s, so we had to get rid of that.
oh, shoot, you're right, with multiply by 2.
Yeah, you gotta multiply this one by 2 as well. So enthalpy also gets multiplied by 2. So if we do that, that should be 180.6. So then you'll get 2 NO, close with our equations together, 2 NO makes N2 plus O2. And then our second one is 2 NOCl makes Cl2 plus 2 NO. So what do we do now?
Now you add all the enthalpies. Oh, you have to take out the intermediates.
Yeah, so NO goes away, the other NO goes away. Now we're gonna go ahead and add in our intermediates. So when we do that right, we'll get,
So they're asking, why are we changing the signs of delta H?
so you change the sign of delta H, right, because you flip the equation. So when you flip the equation, it becomes the opposite sign. Why does it do that? Because if a reaction proceeds exothermic in one way, if you flip the whole equation, right, then it would be going like the opposite way, so it'd be endothermic. That's the whole logic behind flipping this. And this should actually be negative 180. Should it? Yeah, it should. All right, so what's our final step? Yeah, now we just combine our operations. So delta H equals negative 180.6 plus 77.2. When you solve that out, you'll get negative 103.4 kilojoules per liter. Or just kill it in this case. All right, what's this law called? Anybody know? Hess's law, yeah. You have a question?
Shouldn't it first one be reversed too?
Look,
Shouldn't the first one be reversed?
yeah, I think I did reverse it somewhere. Oh, this one.
But then doesn't that make it positive 180?
No, it
Oh,
was
wait,
positive to begin with, so when I reversed it, it became negative.
Okay, I didn't see, or I thought I saw it. I guess I'm bad on full.
Any questions on that? Alright.
So maybe because I haven't got to this point, like in lecture or Alex,
Yeah.
but so all this is new to me, but basically for Hess's law, this is what you have to do. Like you have to like flip equations and all this kind of stuff.
Yeah, you have to flip, multiply through by a coefficient in order to get the equation that it's asking for, which in this case is the one in question. And so you have to manipulate these two equations, and sometimes it'll be more than 2. Like in the one I did on YouTube, there was a total of 4 equations, which those get really hairy. Those are really annoying. But yeah, I think when me and Rich were practicing Hess's law for Gen Chem 1, we found like the most chaotic ones that had like 6 different equations that you had to manipulate and stuff. But you know, the
Yeah.
practice helped us out a
It
lot.
was ridiculous for no reason.
Wait, there's gonna be like 6 different equations on the test?
So
Maybe
Maybe.
not.
yeah, maybe not. So I'm just
Okay.
we did practice.
So-
problem. Yeah.
So essentially, because you're looking for what is in the equation and you flip the like reactions to get that, and then you just like multiply. I guess I'm a little bit lost at the delta H equaling. Like you just add those delta H's together for each equation. Like
Yeah, because the whole point of adding your delta H's together is to get your goal equation. So pretty much when I added the two delta H's together, I got the delta H for my goal equation. Because once I flipped everything, the delta H's should be the exact same. So once I added everything up, I got my goal equation. I added everything together, and that should be our total delta H. Does that make sense?
Yeah, that makes sense. But what about when you canceled out the elements? That doesn't affect the delta H?
No, it shouldn't, right? Because they're intermediates. The intermediates will just cancel out naturally, like when you're doing the reaction. Like it's multiple steps, and then you use the intermediates in subsequent steps. So that's why those cancel out.
Oh, okay, I got you. So they're kind of like not, they're not relevant, basically. Okay.
Are there any other questions?
So like for standard formation reactions, because like on the Alex, they're giving us some and like you have to know like the states of them,
Of what?
the standard formation reaction.
Like the product?
I mean, yeah,
Oh, well, they give us a product. We have to know the state of the reactor.
So you should know any metal is always supposed to be solid because in their elemental form, it's going to be solid.
except mercury.
Yeah.
So mercury is the only exception as a liquid.
As a metal, yeah.
Or like bromine or iodine. Iodine is always a solid at room temperature.
And bromine's always like.
Yeah. Bromine's not a metal, by the way.
Yeah. It's the house.
Exactly, yeah. Sorry, someone in the room thinks bromine's a metal
Oh.
on their exam.
Okay, one last question. I'm sorry, because I haven't like gone over this yet. For NO, there's like one equation has it in the products and the other equation has it in the reactants. Is that so they can cancel out?
Yeah, exactly. Because the whole point, right, is to like add the equations together. And if you see that there's one reactant or like the same reactant, the same product on both sides, you can go ahead and cancel them out as very much possible.
Okay, but they have to be on like opposite sides of like the yield sign. They can't be both in the products.
Yeah, if they're both in the products, you can't do that. But if they're in the ones in the products, ones in the reactants, you can go ahead and cancel them out.
Okay, perfect. Thank you.
Let's do a QR code thing for anyone.
So is the answer for 33 0.0153?
That's probably wrong, actually. I forget, but let me check. 33, you said?
Yeah, 33.
33. Ah. No, it's, wait,
Wait,
wait, what did you say?
0.0153.
Oh, that is correct.
That is crazy.
Hey.
That's crazy. What website did you use for the answer?
Great.
Okay, so please scan the QR code. Even if you're not in this class, scan the QR code, you get 10-cent bonus every time you scan.
That's the wrong number 33, bro. Wait, there's another.
I'm gonna start.
Wait, is it- I don't know if we're good, right?